Just holding on a moment or two while we watch the number of participants increase, but let me at least begin this by welcoming you, those of you who are on board, to this virtual gathering. It's part of the Science in Society series of the Collaboratory, which is a center in the Institute for Neural Computation at the University of California, San Diego. I'm Roger Bingham. I'm the director of the Science Network, and I direct the Collaboratory, where science gets cultured and the culture gets science. This brief video should explain something of what we do. Megan, can you run that? To start a conversation takes just one word. Something on your mind, something in the news, something that science explores. You need a place to ponder the possibilities of that word, the connection to other parts of your life, to history, philosophy, to the arts and humanities, a place to offer your opinions, but always a place where you can discover the facts of the matter, provided by expert guides. That place is the Collaboratory and the Science in Society series, a place to bridge the chasm between the creators and the consumers of science and technology. It begins with a public gathering, followed by student collaborators engaging the guides and imagining tomorrow's world. The first word is conscience. Your guides are Patricia Churchland and Rees Montague. To start a conversation takes just one word. Yes. Join us. So in just one word, the first one, as you saw, was conscience. And the second one we did actually was called loneliness, which we did as a live gathering. All the lonely people, where do they all come from? And they came from all over. They overfilled the room. They were excited. They started talking about having loneliness dinners and getting together. And then, well, that was February the 24th. And shortly afterwards, we went into lockdown. So hence this virtual gathering. We're trying this out. We're very grateful for you to join us. A couple of brief thoughts before I hand over to the participants. Let me just put this in time context. Relentless pace of digital communication in the evolutionary time scale. 3.8 billion years since star stuff became life. 6 million years since bipedal apes. 200,000 years since Homo sapiens. 2,500 years since Plato and the Buddha, 200 years since the beginning of a series of technological and industrial revolutions, 21 years since Google, 16 since Facebook, 14 since Twitter, 10 since Instagram. Every day, 65 million messages, 65 billion messages on WhatsApp, 500 million tweets, 3.5 billion Google searches. We now have an attention span of 8 seconds, 1 second less than a goldfish. So, a couple of quotes that illustrate this whole notion of the processing of information from T.S. Eliot and Cornel West. Eliot said, "Where is the life we have lost in living? Where is the wisdom we've lost in knowledge? And where's the knowledge we've lost in information?" And then there was Cornel West telling a story of his students at Harvard, where he said, "The highest thing a student can say about themselves is they're the smartest in the room. And I tell them," said Cornell, "let the phones be smart, you be wise." So back to Eliot. The only wisdom we can hope to acquire is the wisdom of humility. Humility is endless. The Science in Society series was designed in all humility to create public gatherings and follow-up student gatherings to explore these ideas, not simply interdisciplinary but omnidisciplinary, using a polymathic protocol. Sages and students trading wisdom and learning together. There's a kind of a phrase du jour out there just now, the new normal. I think it could be argued that there is no new normal. If anything, the new normal is flux. To navigate tomorrow's world requires agility and humility. And I suspect that fragility drives agility. So let's find out as I turn this over to Patricia Churchland, Emerita Professor of Philosophy at UC San Diego, and an iconic figure in developing those ideas, notably with her seminal book Neurophilosophy, which became a discipline, and then later Brain Trust, Touching a Nerve, and most recently, as you saw in the video, her book Conscience, which we ended up discussing. So Pat,
thank you, Roger. Thank you. Well, it is my very pleasant duty to introduce each of the three speakers. And so Martin Rees comes to us from Cambridge. As most of you will know, he is a very distinguished cosmologist and astronomer who has helped us to understand much about our universe. Such things as what on Earth are black holes and what are quasars, and why is there background cosmic radiation? Where did the stars and the galaxies come from? And is the Big Bang more plausible than the steady state? Now, fortunately for us, Martin has also had really very broad interests in the fate and future of our species. And we are fortunate that he has a certain kind of wisdom, which Roger remarked on with regard to T.S. Eliot. He has a certain kind of wisdom, which I think we find in these very uncertain times, something that we desperately need, and something which we can appreciate as clear and well-grounded, that gives us something really concrete and solid to hang on to. So I welcome Lord Rees from Cambridge.
Everybody, pleasure to be on this program. Make no mistake, the pandemic should not have struck us unawares. Why did the warnings of Bill Gates and others go unheeded? Why were we so unprepared? I fear the answer is clear. Politicians have strong incentives to prepare for floods, terrorist acts, and for other risks that are likely to materialize in the short term and within their own domain. But they have minimal incentive to address longer term threats that aren't likely to occur while they're still in office and which are global rather than local. These global threats are many and varied and looming ever larger. They're of two kinds. Some, like climate change, are incrementally destructive. We know them well, but fail to develop countermeasures because their worst impact stretches beyond the time horizon of political cycles. It's like the proverbial boiling frog, contented in a warming tank until it's too late to save itself. The second kind of threat, global pandemics and massive cyber attacks, for instance, are immediately destructive and could happen any time. But they're rare enough to be easily ignored, even though the worst could be so devastating that one occurrence is too many. COVID-19 is a wake-up call. It reminds us that our entire interconnected world is getting more fragile, vulnerable to catastrophes that aren't just national, but span the globe. Our generation will be defined in large measure by how we respond to this crisis. We still have an opportunity, an all too narrow window, to dramatically rethink how we minimize the chance of extreme disasters. And I'm going to speculate this afternoon about what the future hazards may be. But first, a disclaimer. In England, I have the title Astronomer Royal, and I'm sometimes asked, do you do the Queen's horoscopes? I respond that I'm not an astrologer. I've got no crystal ball. Indeed, scientists are poor forecasters, though maybe not as bad as economists. So my predictions will be tentative. They draw on my recent book on the future prospects for humanity. And let me briefly show that. In the book, I offer a mix of scientific optimism and political pessimism. The book's theme is this: our Earth has existed for 45 million centuries, but this century is special. It's the first when the main threats are induced by one species, humans. We're deep in what's called the Anthropocene. We have an ever heavier collective footprint on the planet. We're empowered by ever more powerful technologies, which could be hugely beneficial, but which, if misapplied, could trigger catastrophic setbacks to civilization. And such events would be global. We're so interconnected that no continent would be unscathed. Even with a cloudy crystal ball, we can forecast two things about the coming decades. First, the world's getting more crowded. 50 years ago, world population was about 3.5 billion. It's now about 7.7 billion. The growth's been mainly in Asia and is now fastest in Africa. The number of births per year is now going down in most countries, but world population is forecast to rise to about 9 billion by 2050. That's partly because most people in the developing world are young, they're still to have children, and they live longer. And the age histogram in the developing world will become more like it is in the US and Europe. Moreover, the demographic transition is still to occur in sub-Saharan Africa. Population growth seems under-discussed. That's partly perhaps because of association with eugenics in the 20s and 30s, with Mrs. Gandhi's policies, and with China's one-child policy. But also because doom-laden forecasts by, for instance, the Club of Rome in 1972 proved off the mark. As it's turned out, food production has kept pace with rising population. Famines still occur, but they're due to conflict and maldistribution, not overall scarcity. But to feed 9 billion will require further improved agriculture, low-till, water conserving, and GM crops, and maybe dietary innovations, converting insects, highly nutritious and rich in proteins, into palatable food, and eating artificial meat and not beef. To quote Mahatma Gandhi, there'll be enough for everyone's need, but not for everyone's greed. Demographics beyond 2050 are uncertain. It's not even clear whether there'll be a global rise or fall. But if, for whatever reason, families in Africa stay large, then that continent's population could double again by 2100 to 4 billion. Nigeria alone would then have as big a population as Europe and North America added together. Optimists say that each extra mouth brings 2 hands and a brain. But the geopolitical stresses are surely worrying. Those in poor countries now know via the internet what they're missing. They're not fatalistic about the injustice of their fate. And migration's easier. Moreover, the advent of robots and reshoring of manufacturing means that still poor countries can't grow their economies by offering cheap skilled labor, as the Asian tigers did. It's a portent for disaffection and instability, multiple mega versions of the tragic boat people crossing the Mediterranean today. So wealthy nations, especially in Europe, should urgently promote prosperity in Africa, and not just for altruistic reasons. And another thing, if humanity's collective impact pushes too hard, the resultant ecological shock could wipe out many species. We'll be destroying the book of life before we've read it. Already the biomass in humans, cows, and domestic animals is 20 times that in wild mammals. Biodiversity is a crucial component of human well-being. We're clearly harmed if fish stocks dwindle to extinction. Plants in a rainforest may have a gene pool useful to us. Insects are crucial for the food chain and fertilization. But for many environmentalists, preserving the richness of our biosphere has value in its own right. To quote E.O. Wilson, mass extinction is the sin that future generations will least forgive us for. Moreover, these pressures are all aggravated by anthropogenic climate change, an issue which is not under-discussed, though still under-acted upon. Under business as usual scenarios, we can't rule out later this century really catastrophic warming and tipping points triggering long-term trends like the melting of Greenland's ice cap. But even those who accept these scenarios from the IPCC have diverse views on the policy response. Let me expand on this. The Danish campaigner Born Lomborg has bogeyman status among environmentalists, somewhat unfairly because he doesn't contest the science. But his Copenhagen consensus of economists downplays the priority of addressing climate change in comparison with shorter-term ways of helping the world's poor. And that's because he applies a standard discount rate and in effect writes off what happens beyond 2050. But if you care about those who live into the 22nd century and beyond, then as economists like Stern and Weitzman argue, you deem it worth paying an insurance premium now to protect those generations against the worst case scenarios. The case for urgent action to address climate change is compelling. But unless there's a clamor from voters, governments won't properly prioritize measures crucial for future generations. So scientists must enhance their leverage by involvement with NGOs, by blogging and journalism, and by enlisting charismatic individuals and the media to amplify their voice and change the public mindset. Two recent instances. The papal encyclical Laudato Si had a worldwide influence in the lead up to the Paris Climate Conference in 2015. There's no gainsaying the Church's global reach, its long-term vision, and its concern for the world's poor. And in my home country, the UK, I doubt that our government would have introduced legislation to limit non-degradable plastic waste had it not been for the BBC's Blue Planet programme fronted by our secular Pope, David Attenborough, especially the images of albatrosses returning to their nest and regurgitating plastic debris, potentially as iconic an image as the polar bear on the melting ice floe has been for climate campaigns. Climate change is potentially a sort of global fever which somewhat resembles a slow motion version of COVID-19. For instance, both crises accentuate inequality within and between nations. During this pandemic, the lucky ones in advanced countries continue to work from comfortable homes. The less lucky were hunkered down in cramped accommodation, and many lost their jobs. And one plus, incidentally, is that we've had a stark lesson on which jobs really matter. Medics, obviously, but also delivery drivers, carers, and so forth. The current crisis highlights how the status and pay levels correlates disgracefully poorly with the intrinsic value of people's work. And overall, the pandemic is likely to amplify inequalities between rich and poor nations and to cause more human tragedies in the poorer countries of Latin America, Africa, and Asia. Those in megacities like Lagos and Mumbai can't isolate, they don't have sanitation, and medical care is minimal. And likewise, it's those countries and the poorest people in them that will suffer most from global warming and the effect on food production and water supplies. Something else that pandemics and climate change have in common is that coping with both involves more but differently focused science. Biotech is plainly crucial in tackling pandemics for diagnostic, vaccines, and so forth. But it's tough to meet a zero carbon target without drastic speed up in developing novel technologies for energy generation, storage, smart grids, etc. And the developing countries of Asia and Africa can't reach what we consider acceptable living standards without generating more power than they do today, whereas we can get by with less. It's the CO2 emissions from those countries which will matter most to the world and indeed to us. We must hope that their growth will be far greener than ours has been. But if successful R&D in advanced countries leads to more efficient and cheaper carbon-free generation, then we can help India and other vast markets to leapfrog directly to clean energy, rather than building coal-fired power stations. Our efforts in the developed countries could thereby make far bigger differences to the leading global shift towards zero carbon emissions than just what we do in our own countries. Likewise, incidentally, our expertise in plant science could give us special leverage in helping all countries to feed themselves with intensive high-tech agriculture. It would be hard to think of a more inspiring challenge for young scientists and engineers than to deploy and develop technology to provide food and clean energy for ourselves and for the developing world. A few general thoughts now on hopes and fears from advancing technology. We should be evangelists for new technology, not Luddites. Without it, the world can't provide food and sustainable energy for an expanding and more demanding population. But many of us are anxious that it's advancing so fast that we may not properly cope with it. We're ever more dependent on elaborate networks, electric power grids, air traffic control, international finance, just-in-time delivery, globally diverse manufacturing, and so forth. Unless these networks are highly resilient, their manifest benefits could be outweighed by catastrophic, albeit rare, breakdowns, which then cascade globally. Real-world analogues of what happened in 2008 to the financial system. Our cities will be paralyzed without electricity, supermarket shelves empty within days if supply chains were disrupted. Air travel can spread a pandemic worldwide within days, and social media can spread panic and rumor literally at the speed of light. And by the way, pandemics not only spread fast and spread globally, as they did in the past, but they cause far worse societal breakdown today. European towns in the 14th century continued to function even when the Black Death halved their population. In contrast, our societies would be vulnerable to serious unrest as soon as hospitals were overwhelmed, which would occur before the fatality rate was even 1%. And there's likewise huge societal risk from cyber attacks on infrastructure, etc. Advances in microbiology, diagnostics, vaccines, etc., offer prospects of containing pandemics. On the other hand, the rapid advance of biotech will strengthen concerns about the safety of experiments, dissemination of dangerous knowledge, and the ethics of how it's applied. For instance, in 2011, groups in Wisconsin and in Holland showed it was surprisingly easy to make the influenza virus both more virulent and more transmissible. And the federal government ceased funding these gain-of-function experiments for several years. And the new CRISPR-Cas9 techniques for gene editing are hugely promising, but there are already ethical concerns, for instance, about Chinese experiments on embryos and anxiety about possible runaway consequences of gene drive programs to wipe out species. Governments will surely adopt a stringent, precautionary attitude to biotech. But I'd worry that whatever regulations are imposed on prudential or ethical grounds can't be enforced worldwide, any more than the drug laws can or the tax laws. Whatever can be done will be done by someone somewhere. And that's a nightmare. Whereas an atomic bomb can't be built without huge and conspicuous facilities, biotech involves small-scale, dual-use equipment. Indeed, biohacking is burgeoning as a hobby and competitive game. And we know all too well that technical expertise doesn't guarantee balanced rationality. The global village will have its village idiots, and they'll have global range. the rising empowerment of tech-savvy groups, or even individuals empowered by bio and cyber technology will pose an intractable challenge to governments and aggravate the tension between freedom, privacy, and security. These concerns are fairly near term, within 10 or 15 years. Looking to mid-century, we might expect two things. First, a better understanding of the combination of genes that determines key characteristics of humans and animals, and the abilities to synthesize genomes that match these features. If it becomes possible to, as it were, play God on the kitchen table, our ecology and even our species may not long survive unscathed. And if I can venture a futuristic footnote, it's surely credible on a timescale of centuries that human mentality and physique may become malleable by genetic and cyborg technology. This secular intelligent design will change us far faster than Darwinian evolution did. And that's a game changer. When we admire the literature and artifacts surviving from antiquity, we feel an affinity across a time gulf of thousands of years with those ancient artists and their civilizations. But we can have zero confidence that the dominant intelligences a few centuries hence will have any emotional resonance with us, even though they may have an algorithmic understanding of how we behaved. Let me conclude by focusing back closer to the here and now. What can we do? What should we do? My book emphasizes how our society is brittle, interconnected, and vulnerable, becoming ever more fragile. We fret unduly about small risks: air crashes, carcinogens in food, low radiation doses, etc. But we're in denial about some newly emergent threats that could. Some are environmental, the pressures of a growing and more demanding population. Others are potential downsides of new technologies. And a wise mantra is, the unfamiliar is not the same as the improbable. And of course, most of the challenges are global. Coping with the pandemic is plainly a global challenge. And the threats of potential shortages of food, water, and natural resources, and transitioning to low carbon energy can't be solved by each nation separately. Nor can the regulation of threatening innovations, especially those spearheaded by globe-spanning commercial conglomerates. Indeed, the key issue is whether in a new world order, nations need to give up more sovereignty to new organizations along the lines of the IAEA, the World Health Organization, etc. Scientists have an obligation to promote beneficial applications of their work and to warn against the downsides. Universities can use their staff's expertise and convening power to assess which of these scary scenarios and echo threats or risks from misapplied technologies can be dismissed as science fiction and how best to avoid the serious ones. Politicians focus on immediate threats like COVID-19, but they won't prioritize the global and long-term measures needed to deal with climate and biodiversity threats, unless the press and their inboxes keep these high on their agenda. As I said earlier, scientists must enhance their leverage by involvement with NGOs, blogging and journalism, and enlisting charismatic individuals in the media to amplify their voice. Politicians will sometimes make wise long-term decisions, but only if they feel they won't lose votes thereby. And it's encouraging to witness more activists, especially among the young, who can hope to live to the end of the century. Their campaigning is welcome. Their commitment gives ground for hope. Spaceship Earth is hurtling through the void. Its passengers are anxious and fractious. The life support system is vulnerable to disruption and breakdowns, but there's too little planning, too little horizon scanning. We need to think globally. We need to think rationally. We need to think long-term, empowered by 21st century science, but guided by values that science alone can't provide. Thank you very much for listening.
Thank you so much, Martin Rees. And in particular, thank you for being so forthright for getting us into a mindset where we can both face these things but not be so overwhelmed by the impending disaster that we give up. So many thanks for a very, very wise discussion. I must now turn to John Doyle. John Doyle is a bioengineer at California Institute of Technology, otherwise known as Caltech. John Doyle works on dynamical systems and control in dynamical systems. So he's interested in such things as the trade-off between speed and accuracy, or between robustness and efficiency. And we can, of course, appreciate fairly quickly how those things, how that understanding applies to invented devices. But it turns out, of course, that it also applies to evolved things. And I think, in addition, some of these central ideas about control in dynamical systems applies also to social groups. And it will help us understand something about the kinds of choices that we need to make. As Martin Rees said, we can't sacrifice concern for the long term by focusing narrowly on the short term, for example. And yet we all have a tendency to do that because it's upfront. So John, if you are ready, I will hand the microphone and the space to you.
Okay. Can everybody see that?
Yes.
I'd like to go a little more deeply into the fragilities that have been exposed recently. You are presumably using some app to remotely view this webinar or video, and those apps are networked. But a term we've come to use a lot recently is virtual, and I want to spend a little time on that. So virtual has all sorts of colloquial meanings, but I am going to use it in a somewhat more technical way, the way it's used in computer networking, and then try to expand on that. So the apps that we're using are networked, and that enables them to share videos and files and so on. But the apps themselves are quite diverse. There's a lot of different ones, and they're swappable in the sense that we can get them from others and then network them. So in this context, what does virtual mean? So one aspect of virtual is that the apps are not directly connected to each other. They're connected via an operating system, as shown here. That operating system is also networked, but it is not swappable and not very diverse. So we would say the applications are connected virtually. But of course the OSs are also software, and they're sitting on top of a physical hardware, and there are physical connections there. So these connections are virtual, and then we do have real physical connections. And then the physical hardware is also networked, and it's moderately swappable and moderately diverse. So the applications are in a virtual network, but the supporting infrastructure of software and hardware is virtualized in the sense that when you're using the applications, you don't see those details. You do see some aspects of the hardware, for example, the keyboard and the screen, but all of the complexity of that hardware, the processors and the memory and so on, are all hidden and virtualized, as is the operating system. This is no accident, because virtualization and layering are what makes it possible for the apps to be networked and be so swappable and diverse. So when we aren't in a network, when we're just on our machine, we're also using virtualization. We see some, again, bits of the hardware, but most of the hardware is hidden, and all of the operating system is hidden. And that's what we're calling virtualization. And if there's a user, they are also doing a lot that's automatic and unconscious. So you could think of that as an aspect of virtualization within humans. But when you're connected to a network, then essentially all the resources of that network then become virtual from the point of view of the user. So we call this a diversity hourglass. in that you have diverse and swappable apps sitting on top of moderately diverse and swappable hardware, and in the middle, a not diverse and not swappable operating system. An important concept is that of law or trade-off, in this case between speed and accuracy. Ideally, every one of your parts would be fast, accurate, and flexible, but unfortunately, none of the individual parts are. For example, if you want maximum speed, then you'd ideally like a function to be implemented in special purpose hardware. But it's the software that gives you the flexibility at some expense in speed. Of course, software can't run by itself. It needs to be run on hardware, and in this case, that's virtualized by an operating system. But what you can do is create a diversity-enabled sweet spot. What that means is, if you do everything in just the right place, you can get all the flexibility and accuracy of software, but with speed that's nearly that of hardware. And that's a diversity-enabled sweet spot. The diversity of the different layers doesn't by itself create the sweet spot, but it makes it possible to. And that's why we call it a diversity-enabled sweet spot. Another very different system, but one that has some of these architectural features, is biology. And in particular, we'll start with simple biology, which is bacterial cells. So these also have a diversity hourglass with diverse and swappable genes sitting on top of diverse and swappable proteins, with a operating system that is not at all diverse and swappable. The operating system here is the transcription and translation protocols and associated machinery. And this is networked, but not at all swappable and not at all diverse. It is possible to have hardware-only biology. Some eukaryotes, internally differentiated cells like red blood cells, jettison the genes and jettison the genetic material and the transcription and translation machinery and have just protein networks. And this is fast and very efficient, but you lose a lot of flexibility. So these are very specific functions that are done by these cells. Now, the control of biology in the bacterial cell is also done most fast and most efficient in proteins. It allows this diversity-enabled sweet spot by which you can turn on different genes, create different proteins, so that you can be nearly as fast as having just all proteins with the flexibility of genes. And this flexibility is used in all sorts of processes. For example, horizontal gene transfer in bacteria, sexual recombination in higher organisms, selective breeding takes advantage of this, and genetic engineering does as well. A side effect is that horizontal gene transfer can be used by bacteria to swap around antibiotic resistance, which is great for the bacteria, but bad for us. Also, this swappability means that viral genes can also be swapped in and hijack this. So we have these two extremely different systems that nevertheless share a lot of architectural features, which we're highlighting here. And they both use virtualization in the sense that from the perspective of the genes or the perspective of the apps, a lot of the details are hidden in the operating system, and so you don't see all the hardware details. And this creates diversity-enabled sweet spots in both systems. So all of these mechanisms are facilitated by this virtualization. Another example, again, very different, is layered language. And again, we're going to take a pretty superficial view of this. But here the idea is that we have very diverse memes that we're swapping all the time. And we have diverse sounds that we can make with our vocal hardware. And then we have an operating system sitting in the middle, which we can sort of think of as including grammar and a few other things. And it has to be shared. If we don't have a shared language, then we can't talk to each other, even if we have common hardware, and even if we have common ideas. If we don't have a shared language, a shared operating system, then we can't create this diversity-enabled sweet spot. So right now, we're doing horizontal transfer of memes, things like architecture and speed factor trade-offs and diversity-enabled sweet spots and laws and layers and so on. And so we're able to do that using English because presumably everyone here is knowledgeable in English. Now, language has a layered architecture. Again, I'm grossly oversimplifying it, but the idea is that we could explicitly look at the grammar of this sentence and graph it out in detail and analyze it. But of course, that's not what we actually do when we're speaking and listening. This is all, again, virtualized, unconscious, and automatic. So the shared OS that enables horizontal transfer greatly accelerates evolvability, both in biology and in our technologies and in culture and society. All of these leverage the shared operating systems and the fact that horizontal transfer is enabled by them to create diversity-enabled sweet spots. So let's kind of summarize a bit of what we've learned about architecture in this way. So first of all, we tend to use the word law quite loosely to say all the constraints from wherever they come that constrain what it's possible to build out of the available components. In this case, we're saying some of our components are hardware, some of our components are software. One aspect of architecture is then to be able to build a variety of components that are allowed by the law. And finally, the aspect of virtualization is that you can create a sweet spot, and that's another element of architecture. And notice that it's a diversity-enabled sweet spot. The diversity by itself doesn't create the sweet spot. It creates the possibility. But then if you use virtualization, you can create this diversity-enabled sweet spot. So this is great. These systems are so successful that they have all completely taken over the world. But what can go wrong? So we've seen that this horizontal transfer enables all this evolvability in these three systems. But this universality is exploited by viruses. Now, predators don't care about architecture. They can destroy it and just consume the hardware building blocks. But parasites hijack architectures. So what they do is they leave much of the architecture intact and hijack it for their own purposes. So here are the top 40 human infectious diseases. They're all familiar, presumably, to you, and they have incredibly diverse symptoms and incredibly diverse pathogens. Of course, we now have a new one to add to the list. So all of these hijack our physiology in our machinery and to reproduce. The swappability of our computer systems and the software there allows for a type of software that's called malware. And there's, again, a huge diversity of it, and it threatens everything we do that involves cyber infrastructure. We also have memes that are quite popular and very dangerous. And here's a somewhat whimsical list of possibilities. Social media has proved to be particularly vulnerable to hijacking, and it combines both apps and memes. So what else can go wrong? So one of the things we'd like to look at is broader aspects of this architecture of fragility, and particularly motivated by systemic racism. So we could ask, from this perspective, what does our legal and justice system look like? What is its architecture? And a starting point in trying to understand what the architecture is, say, oh, what's the hardware? Well, the hardware seems to be police, the corrections institutions, parole boards, and so on. So I'm going to superficially say, let's look at this architecture where we say the police are the fast local response. The courts are slower and hopefully more accurate. And then finally, the legislature writes the code, and hopefully it is also even more accurate and more flexible, but obviously slower. Now, from the perspective of being outside the legal system, you don't see these details. So in some sense, we could call the legal system to be largely virtualized. But what we do see is systemic racism, and we want to try to understand that better. What I'm going to argue is that systemic racism is certainly present in policing now, but that the deeper systemic racism pervades the whole architecture. And not only that, but we have systemic fragilities that are amplified by the architecture that we have for the legal system. So we want to look into that a little bit more. So one of the questions is, how does this get hijacked? In principle, this works to help benefit all of us. So our Constitution established civil rights along with the Bill of Rights for rich white men, but it was later amended by the 13th Amendment, which ended slavery, the 14th, which added civil rights to former slaves, the 15th that gave them the vote, at least in principle, and that was just for men, and the 19th then added it for women. Again, all in principle. So I'm going to focus on the 14th Amendment, which in principle gave civil rights to former slaves, but in fact has been quite hijacked. So the 14th Amendment, it again in principle gave former slaves civil rights, but slaves are never mentioned, and it's quite vague here in some respects, and that I think helped it be hijacked. So the real civil rights movement has been quite different in the sense that the Supreme Court has used the 14th Amendment to undermine civil rights of former slaves. So the separate but equal ruling enshrined segregation in the Plessy in 1896, but also more recently, the 14th Amendment has been used to shield excessively violent police from either civil action with this notion of qualified immunity or from criminal prosecution with the malicious or sadistic intent standard, which is essentially impossible to satisfy. It also prevented local jurisdictions gun laws, which is not quite so important for our argument. So what we have is that the 14th Amendment actually rolled back civil rights and made systematic racism pervasive throughout the justice system. It was the separate but equal, qualified immunity, and malicious intent were all based on the 14th Amendment, though not exclusively. And they've been blunted to some extent since, but not entirely. And so the argument here is that it's architecture, not individuals. While individual responsibility is still crucial, that alone is not enough, and we have to go after this systemic racism. And it's not just systemic racism in police, but it's systemic racism throughout the entire system. But it gets worse. The 14th Amendment has been used less than 30 times to promote the civil rights of African Americans, and more than 10 times as much for corporations. So corporations have been the real benefit of the civil rights movement. So this is a cartoon that sort of shows a little bit of what a corporation does. It moves materials and services around and gets money in return and moves money around. But all of this litigation about the civil rights of corporations has meant that they have converged to this system where they only benefit their shareholders and otherwise can create systemic fragilities everywhere. And this is not simply shell companies. This is real corporations that have real world impact, like climate change. And they're almost zombies in the sense that they have no responsibilities except to their shareholders. And this is a pervasive example of systemic fragility. So the systemic racism and systemic fragility are really baked into this architecture now by hijacking. So even the 14th Amendment, which was arguably the cornerstone of the civil rights movement, has been hijacked and essentially virtualized, so we now kind of have a zombie law. And so we see systemic racism in our policing, but it comes from much deeper systemic racism and systemic fragility. So what we need to do is undo this hijacking. We're not going to get rid of virtualization. We need that, but we need to make it more transparent or selectively more transparent. And hopefully we can create a diversity-enabled sweet spot, which would get rid of some of these fragilities, get rid of systemic racism, but it's going to take very concerted effort across the board. And lots more details and videos and papers and slides and so on can be seen at my website.
All right. Thank you so much for that perspective, John. It's, I think, really refreshing to see a sort of take on things that is is not just the standard one that you get from the New York Times. I think that's really brilliant. I should perhaps just take a moment also to say that in Zoom there is an icon for questions and answers. And for those of you who wish to ask a question, if you could click on that and then go ahead and write your question. And our next speaker is going to go through those questions and try to make them concise and clear if that's what they need, and then open it up to others to address those questions. So Terry Sejnowski is our next, excuse me, Terry Sejnowski is our next speaker. As many of you know, Terry heads up the computational neuroscience lab at the Salk Institute here in San Diego. He has written a book called The Deep Learning Revolution. And it's a very special book because it's not just about other people and what they did, but because Terry, along with Jeff Hinton in particular, were major players in this deep learning revolution. It's a wonderfully clear and really informative book. And like our other speakers, Terry thinks beyond the confines of the particular research that's being done in his lab to address the wider questions that are of great concern to us as social beings, as beings who are dependent on one another, who have connections to one another. And so, Terry, I'm going to turn this over to you now, and I know that you will also be the one to look at the questions as they are submitted on the question and answer icon.
Okay, can you hear me? Good. So I want to thank the two previous speakers for just setting up a wonderful discussion that we're about to have. Martin has given us a penetrating look at fragilities on timescales ranging from years to centuries. The risks are existential, and by that I mean our existence is threatened. John has given us a peek into the how large-scale complex systems, both biological and engineered, are organized, and how fragilities arise in them. So, so we would like now to take a closer look at where we are and where we should go. I mean, what can we expect over the next 5 to 10 years, first of all, as a consequence of COVID? It's something that's in everybody's mind right now. But I think on an even larger time scale, what can we do about problems like climate change and changes in our society? These are, they take generations to change, and it's not going to happen in the next few years or even the next few decades. But to get a few hints, I want to give you one example, and this is something that occurred during World War II. This is back in the 1940s. And in all previous wars, the majority of deaths were not from battlefield injuries, they were from infectious diseases that were consequences of those injuries, or just malaria, depending on where in the world the war was taking place. And World War II was different because of penicillin. But the problem was that it was very difficult to produce it, to mass produce it. And so all the leading pharmaceutical firms, the Mercks, the Squibbs, and the Pfizers, pooled their resources, their research, their technology, in order to mass produce enough doses so that on D-Day in 1944, there was enough penicillin to treat 40,000 troops. And as a consequence, there were many, many fewer deaths than there otherwise would have been. Now, what was interesting is that the same thing is happening now. We can see all of the pharmas are getting together to try to mass produce vaccines. It's going to be a monumental effort. It's going to require all, all in that and it's not just the manufacturers and the pharma, it's the scientists who are now banding together and trying to pool their knowledge. So this is a global effort, and it's very rare that that happens, because otherwise these companies compete and scientists like to get credit for what they're doing in their own lab. Now, there was another knock-on, which had to do with what happened after the war. And this is even more remarkable because of the fact that there was so much exchange. I mean, these are, in John's words, memes, but also, knowledge. That there was an incredible burgeoning of innovation in the world of medical discoveries, and it opens a possibility that maybe one of the consequences of what's going on today is that the medical system and the way that the corporations work will have, in some deep sense, will have changed. There's, we're having this remote meeting. I can tell you that having my Zoom lectures this quarter has been eye-opening in the sense that it's completely different and it has different strengths and weaknesses. But what we're experiencing right now is the Model T of what is going to be available 10 years from now because of virtual reality and augmented reality. It'll be 100 times, 1,000 times more interactive. And so we're living through this period where this technology is coming online, and what's happening right now is it's being accelerated. Something that would have taken a couple of decades has occurred literally within a few months in terms of giving classes. So this is something, and meetings that are now virtualized. So I am the president of a foundation, the Neural Information Processing Systems Foundation, that last year held a meeting in Vancouver for 13,000 people, physical meeting. This is the premier meeting in machine learning and artificial intelligence. Well, this year it's going to be virtual. And as a consequence, we're expecting probably 2 or 3 times as many people to tune in because of the fact that it doesn't matter where you are in the world, you can participate. And that is going to have a major, major impact on the way meetings are organized in the future.